Ignite students, we are ready to go. It's a good day. Here we go. Metamorphic rock. We've done sedimentary, we've done igneous. We are now at metamorphic rock. Excuse me. Here we go. So metamorphic rocks are things that are changed by heat and pressure, okay? What's interesting is you're taking a rock, you're just going to heat it up, you're going to squish it a little bit, and somehow it's a new rock. It should just be the same rock. In the same way that caterpillars and butterflies are different, the rock that you started with and the rock after metamorphosis can be very different things, okay? But what's interesting, of course, is that, well, we've got things that have just a little change from their parent rock to things that have a lot of change from their parent rock, okay? So over here, the thing you start with, the thing it becomes, it's a metamorphic rock, and we'll get into some of that. Let's look at this guy right here. Metamorphosis occurs when you have an increased temperature and an increased pressure. These conditions happen a few kilometers below the surface of the earth, down all the way to the upper mantle. Okay? Two major types of metamorphosis that we're going to deal with: contact metamorphosis and regional metamorphosis. Very different. Contact metamorphosis, real simple. When magma comes up and intrudes a rock formation, you have heat that's going to change that rock. You're already under pressure. You're squishing magma up through there. Your increased pressure, your increased temperature, something's going to change in those surrounding rocks as they start to melt. So sometimes they will recrystallize. Sometimes they'll just change their crystal structure. Okay. Often this contact metamorphosis is just minor changes, not necessarily huge. Marble, the biggest one is limestone turns to marble. When you put magma in a bunch of limestone, you get marble out the other side after time and pressure and temperature. Okay. Regional metamorphosis, though, by the way, over here, this says thermal on your screen. That's contact metamorphism. Okay. So you got the magma coming in, you've got marble as a result. The magma is coming into limestone. And you may see some other things down here, gnesis and different things happening. That's at a higher pressure. We're going to talk about that. Over here is regional metamorphism. In other words, where you have entire plates pushing up and forming mountains, or diving under another plate and you've got a subduction zone. Wherever entire tectonic plates are moving, there's a little bit of pressure. That's regional metamorphism, because the entire mountain is made of a rock that's different than it was before the plate slammed into each other. That's what regional metamorphosis is about. Usually the regional metamorphism is a bigger change. So that's high grade metamorphism, and the contact is usually a low grade metamorphism, meaning fewer changes with magma than with giant mountain pressures. Okay. But there are things, so what actually does the changing? There are several agents. Agents are things that do the thing, right? The thing that does the thing, that makes the thing, right? So the agents: heat, pressure, and reactants in solution, okay, or reaction in solution. Biggest one, heat. In fact, there's two types of heat. So we had three things, and now there's heat, and then heat has two subtypes. Heat can come from magma, or heat can come from just the fact that temperature increases as you go lower. As you increase depth, temperature increases. So either the temperature comes because you're lower, down here where you've got gnesis versus limestone stuff happening, or temperature increases as temperature increases near magma. Sorry. I almost went to pressure there. Heat is the most important agent. Heat, when you add heat, is energy. And this energy is used to drive and speed up any chemical reaction that's going to happen in the new metamorphic rock to change it from whatever it was. It could have been sedimentary, it could have been igneous, but now it's going to become metamorphic. So heat can either recrystallize existing minerals or it can cause new minerals to form. All right, we talked about the two types of heat, magma and depth. Pressure also increases with depth. What's interesting though, as you just increase pressure, the space between the crystals actually shrinks. There's less dead space, or the crystals have to align better to fit. And as we're doing this, the rock tends to not soften, not melt, but it tends to flow instead of fracture. So it's going to smooth out instead of break. That's going to cause a couple things, because now all the mineral grains, which were all sorts of different ways, are going to start to flatten out, and they're going to start to elongate because of the pressure on them. Because they can't be random. You're putting too much pressure on them, so they're all going to have to organize. And as you get the rock under lots of pressure or lots of heat, that happens. And then now you increase pressure, they're going to elongate also. All right. Reaction in solution. All right, this is the one nobody really talks about. Here. You can have hydrothermal metamorphism. So not just contact metamorphism or regional metamorphism. If you start talking about hydrothermal, the solutions, all right, sorry, I can't point like this. This doesn't work. This is on the ocean floor. You have hydrothermal vents. You have basically magma right below the surface of the ocean. And as that magma comes up, you get all sorts of funky gases and minerals and all this stuff, and you're forming rock right here. That's metamorphic rock. Geysers, Yellowstone, with weird elements, sulfur, phosphorus, who knows what is, we know what, but there's also a lot of variation for this other minerals that are in this water, which is why you get all those crazy colors in the pools and the rocks that form near hydrothermal vents. All right, let's look at some other stuff here. This whole regional thing, folded mountains. What's a folded mountain? These are crazy pictures that you could see where entire regions, let's see here's a person for scale. The entire region is being pushed up as the mountain forms, and the rock layers are folding. They're elongating, they're folding, and that's a regional metamorphosis. All right. What do we have here? This is interesting. All right. What you start with, let's zoom in. Shale. Shale turns to slate. Slate turns to phyllite. Phyllite to schist. Schist to gneissus. This shale is a sedimentary rock. This is metamorphic. This is metamorphic. This is metamorphic. This is metamorphic. But it's increasing metamorphism. All right. So we got to zoom out here. Zoom in over here. Sandstone. Sandstone's a sedimentary rock. It becomes, over here, where's my scroll bars gone? It becomes quartzite. Quartz type. Granite is a different way to become gneissus. Granite's an igneous rock. It can become a gneissus metamorphic rock. Basaltic is an igneous rock. Okay, it can also become a schist. Limestone becomes marble. Parent rock, metamorphic rock. Here we go. So what we have, shale, mudstone or siltstone, very fine. So we're going to classify again based on foliated and non-foliated. Okay, we got to pause. Foliated is layered. Non-foliated is rock without banded textures. So if you don't get bands and stripes, it's non-foliated. If you have bands and stripes, you're foliated. So we're going to split all of our metamorphic rock into stripes and polka dots. All right. There's something kind of interesting. Usually these charts show fine to coarse. Down here, it's reversed. They show coarse to fine, and that's fine. So slate comes from shale. Slate looks very, very, very much like shale. It's just a little thicker, harder. Shale is real thin, peels off, fractures real easy by hand. Slate won't do that. Slate's not crazy hard, but slate can be ground very smooth. It can be made into a pool table. Slate is old school blackboards, not whiteboards. That's what slate is. All right. What about this? Phyllite, schist. What about a gneiss? Something saw something that's very fine. What about something that's very coarse? So these are gneiss rocks. All right, and you can see foliated layers in there in all of these. And the other thing that's interesting, so if these layers go side to side, it's because the pressure was up and down and squished all the layers out perpendicular to it. So if you see layers in this direction, then you know the pressure was from top and bottom. And they laid this rock sideways, so pressure would have been from this side and this side. So there's some gneiss rocks. Okay. Marble. Well, when you just Google marble, you get lots of things like marble countertops, but here are marble rocks. Marble comes from limestone. So when magma intrudes, so it is a contact metamorphosis, intrudes the limestone, it becomes marble. All right, limestone is a sedimentary rock, becomes marble. This is a metamorphic rock. So there's marble. Anthracite. Woo, look at that shine. You take coal and you turn it metamorphic. You get anthracite. You get an entirely new rock just by heat and pressure. All right. There's some other little things in here going on. Let's see. We saw that one. We saw that one. So, real quick. Slate, phyllite, schist, gneiss. Wait a minute. Slate, phyllite, schist, gneiss. So what that's saying is that this little arrow right here, increasing metamorphism, probably either the more pressure it was under, the longer it was there, or the closer to the magma it was, the more the rock changed. Because if you start with shale and it becomes slate, slate then can become phyllite. Phyllite can become schist. And schist or granite or other volcanic rocks, lots of different things, can become gneiss, layered, very layered like that. So that's what this progression is down here. And then you've got one here, here, depending on what you start. So granite can become a gneiss, or a schist can become a gneiss. So that's kind of it. Metamorphic rocks change because of heat and pressure. That's it. They change because of heat and pressure. They don't always look like their parent rock. It's good stuff. All right. We have wrapped up. We are very near the end. We're going to have a review. Wednesday or so, we'll open up the test at the end of this week. You need to do that test, and then we'll have some stuff to review and get ready for the final. Your moon projects. Make sure you submit the moon projects. Submit the moon projects. We got to hide this or I can't close out. Guys, have a great day.